Thank you so much for joining in. Okay. Is my voice audible? If I'm audible, right? Hey, Lisa. Thanks, Yamini. Thanks, Regression. Thanks, Gokul. So, thanks, Tejas. Smita, Anita, Smita, 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 Venkatam. Thank you so much. Thank you so much. Great. Okay, so first I'm going to welcome all the people who have recently joined the community. Thank you so much for joining. So can people who have recently joined, like within the past 1 month, if you have joined within the past 1 month, type me in the chat box. Great. People who are watching us on our social channels, you can type me in the chat box or on your YouTube or LinkedIn, or you can also use the comment section. Okay. So, sir, I see that you have recently joined. So you can let us know. Okay, great. So in today's session, we're going to learn about multiple linear regression. But before that, if we just point you in the direction where what we are learning. Okay, so let me go ahead and share this. Let me know if my screen starts becoming visible. Okay, great. So if you log into your Teachable, you'll be able to see these sessions, right? So you'll be able to see that introduction to Python, exploratory data analysis, and all these modules. So basically, people who have recently joined, you can start from the beginning, right? So you can go ahead, like Sumit sir, you can go ahead and start from here. So when you start from here, it will take you from the scratch, right? So it will, assume that the foundations also have to be taught, and the module begins from there, right? So the current revision hackathon is, we have completed, we have revised all the modules. So the model of the revision hackathon is we are going to revise the concepts covered by the primary faculty. Here in this case, either Jain sir or Rajiv sir. Okay, so now we have finished covering these modules from 1.1 till 3.2 we have covered, and today we are going for 3.3 multiple linear regression. So many of you might be kind of parachuting into this particular lecture because you have recently joined. Do not worry, the revision hackathons happen in a cyclic fashion. So we'll finish all of these modules and then start from the beginning, right? So start revising from the beginning. So do not worry if at all, you are kind of just starting off today and finding yourself in the middle of the course. But alternatively, what you can do is you can start from here and continue in a sequential manner. Okay, so there are two ways. Either you can go through the parallel course and also join the revision hackathon so that you cover both. Revision hackathon, maybe you might miss out on a few concepts, but you will have an understanding why you come in the primary lecture, right? So that will be a beneficial thing for you, right? So if that is clear, type C in chat, especially members who have recently. Thank you so much. Great. Okay, so I'm just going to check with my chat. Yeah, so I think chat is enabled forever. Okay, so let's go ahead and start with 3.3. And how do you find the collab file? So people who have recently joined, collab file is where we run our programs. So you do not have to install Python on your system. Collab is an offering from Google where you can, run your, Python files. So I'm just going to open Collab from here. I'm also going to share a link. You can even access Collab from there, right? Okay. So let me go ahead and share today's Collab file. I'm going to share this. Just going to give it to everyone here. So people, so you can just go ahead and click on this link. People here, if you have recently joined also, let me just go ahead and just show you what to do. So once you open this on your browser, it will ask you to go ahead and click on file and click on save a copy in Drive. So what happens is it will create a copy and save it on your Drive, right? So you can access and make edits from it. Right. So these notebooks, now if you see uh, on each of the session, you can see towards the end, like for example, 3.3, here is the lecture video. Now you can go to the lecture here. This is an unlisted video visible for you to access. And then here there is the download multiple regression IPYM. Right. So when you click on it, it will also open up and you just have to click on open this collab. I hope that is clear here. Right, so I hope you answered. You can even click on the link that I've shared on Zoom chat. Okay, great. So in our previous session, what we have done is we have understood more about how to infer and get insights from linear regression and different kinds of regression, where we have seen multiple data sets, and towards the end we have also seen data set that was related to the long ball, right? So if you remember, we have assessed this particular data set, which was helpful in understanding how to infer and how to make edits when you are trying to make an inference, right? So the correlation is something that we have explored in our previous session, right? So now in today's session, what we're going to do is we are going to learn more about multiple regression. So many times what happens is when you make a graph, right, x y is changing with x, but many times what happens is there are multiple variables that are going to impact y, not just one variable which is x, right? So we are going to understand that. So we are going to model the relationship of multi-predictor variables to a single outcome, right? So we'll try to understand that. Just to give you a overview example. For example, if you're trying to take the purchase of a house, there are multiple elements that affect the price, right? So sometimes it is the location, area of it, and if it is independent house or if it is an apartment. So there are multiple things. You cannot just say the price will only depend on one thing. Price will majorly dependent on the location, but there are other factors also which will affect the price, right? So we'll try to understand how to make a correlation among those variables, right? Yes, Yamini. So for Yamini's question is for bronze subscription, also the notebooks are available or not. So yes, for bronze also there are the portion of modules that are available only for bronze modules, and in that the respective Collab files or notebooks are available. Okay, so most of the sessions you'll be able to see that. Yeah, so Ritesh, now if you are joining the sessions of Rajesh are happening currently, you are already accessing part of it, right? So yeah, but it will be covered deeply with all the collab files, everything will be good. Yeah. So now you have understood more of machine learning, and yeah, thank you so much. Now we'll also try to understand. Yesterday we have also in our previous session we've also seen how to get the model summary. So we have left out a few variables there to be discussed in our next sessions. We're also going to understand that. Okay. Now what is the objective? First objective, model the relationship of multiple predictor variables, right? So we'll try to keep this particular session between the stipulated time. Now, if at all you have seen the same the data set long goals which we have discussed previously, we are going to import that. So for the people who have recently joined, so what this does is we have covered how to import in our previous sessions, but there will be CSV files like Excel files, and we are going to import, like now if you see this particular data set, we are going to import in something called a data frame, which will be helpful for us to operate on it, right? So this is what the operation we are trying to do here, right? So let me go ahead and do that. So once you first click on this particular button, it will run your code in that particular cell. If at all you have not clicked on connect here, it will automatically connect, right? Else you might have to click on connect here so that this collab file allocates a little of RAM and disk space for you to run your code. Okay. Yes. Okay. Yeah. You have shared an image. Sorry. Yeah, so I think the particular session that Yami you have mentioned, in the first one itself, you'll file the collab file. In the one, is the title is one. In pandas itself, you'll find the numpy is collab file. Thanks for sharing. Help. I mean, thanks for sharing the image. It became more clear, right? Okay. So I request you to focus on this segment. If you have any specific query, or you can always reach out. Yeah. Is my voice not clear? If my voice is not clear, type. Let me know in the chat. Okay, sir. Okay. I think it should be better now. Is it better now? Okay, thank you so much. Okay, so voice has a lot of importance, especially in terms of engagement, because more messages are coming out. Thank you so much. I think whenever you notice, especially people like Ritesh, Vinita, if you ever notice my voice is not clear, because I do a check every time, right? If my voice is clear, if you ever feel that my voice is not clear, you can just go ahead and tell me. So in today's session, we are going to start with the multiple regression. In our previous sessions, we have understood linear regression and understanding of how to infer or make insights from it, right? So now we are going to import the data set, which was long ones. So for people who have not attended our previous session or joined recently, do not worry, we have covered this at length in our previous session, right? So here what we are trying to do is I'm just going to import whatever records are there in this particular CSV file by using a Python command which is called read_CSV, right? So now this particular variable will have all the data of that particular data set, right? So of that particular CSV file. So now what we are going to do here is we are going to drop NA. If you remember in our previous sessions, we have cleared wherever there was a null value, right? So because my voice was not clear, so people who have recently joined, do not worry. You can either start from the beginning from here, else you can continue going through the session and also parallelly go from the start, right? So both of it, both the approaches are good. So all these sessions will be repeated in cycle once again, right? So once we finish till the certification, we are going to start from the beginning, right? So you can either do both the actual lecture and the revision hackathon. The revision hackathon might be moving, but the other approach is you can also go through the actual lecture and the recording of the revision hackathon, which will be there in your inner circle module.
Great. Now, so we have, this is our data set. We have seen the data set. In this data set, there are multiple columns: site, time, depth, live, age, nitro, oil. So now what we have seen is the dependency of time on nitro, right? So now what I'm going to do is I'm going to similarly, like last time, we are going to use the equation as time tilde nitro. So what this does is, this is going to give me a summary, right? So people who have not attended our previous session, do not worry. So this is just something that we have covered in our previous session only, right? So what this does is, it is something to say like, make the equation y related to x, right? So this is what is being told here. And there are multiple methods in Python. One of them is OLS, which is taken from the library, which is a default library in Python, right? You can import a few functions from here. So which is statsmodel.formula.api. From that, we are only importing OLS. So when you do that, you will be able to run this function OLS. So when you run this and print model.summary, there will be a little insights that come in, right? So previously we have seen these two lines, which is the the nitro and the intercept, right? So nitro is something that is more important. Now, something that we have not discussed previously is r square and adjusted r square. So in this today's session, we're going to understand more about it, right? So we have understood something about the correlation coefficient, right? So now if at all we have to make an equation out of it, so the equation would be like this, right? Previously, y equal to this, minus 69.24x plus 316. So because y is equal to mx plus c would be that equation, right? Now, sometimes what happens is, not whole of the variable y is dependent on nitro, right? So like one example that I'm giving, I'm not sure if my voice was clear. For example, if you're trying to make a purchase of a real estate or a home, there would be multiple variables that will impact the price. For example, it could be the location, it could be the SFT, it could be, right? If it is an apartment or if it's an individual house, there are multiple variables that will affect the price of it. Now, what we have done here is we have compared with time with nitro. Out of all these columns, we have compared time over nitro, and this r square, what it does is it tells that the variability of y on the x that you have given on nitro is 45%. So r square is gives that whatever you have compared previously, the times dependency on nitro is 45%, right? So meaning out of 100% dependency, what happened here is only 45% you are able to validate, right? So you're not able to get more of it. Okay, so Vijay asks for the collab file link. I've just shared it. So I'm going to share it once again here. Okay. Amazing. Thank you so much. So let us try to understand the actual definition. I've given you the dependency of it, but let's try to understand the definition of it. And within the session, sir says like most of the things you might not have to remember in your programming, because there's always a search at your disposal. There'll be a few things that you need to remember, and the definition of R square is something like that. You need to remember it. Yeah, so Ritesh asks a question. Yes, Sumaya, I think you can go ahead and start from the beginning. So you can start from here, right? And if you require any assistance, definitely do reach out. Okay. Thank you so much. So now Ritesh says, sir, can we say that R squared value is the measure of correlation between the dependent and the independent variable, or are they different? Right. So you are, almost there, Ritesh. You are absolutely there. So let me just go ahead and go through the actual definition here. So now R squared is equal to the square of the correlation coefficient, right? If you remember the correlation coefficient, it is the square of the correlation coefficient. It's a number between 0 and 1, and that it is often expressed as a percent. The interpretation of R squared is the percent of the variability in Y variable that is explained by the difference in X variables, right? So we'll try to, simple to understand is it is the percent of variability in Y based upon what X variables you are taking, right? So we'll go forward and try to understand further. Now, in this case, R square equal to 0.45, the interpretation is the 45% of the variability in the time is explained by the difference in nitrogen composition of the long bones, right? That means that 55% of the variability in the time remains unexplained by this particular model, right? So it is not explained. So now that is where it was linear regression, right? So now we'll have multiple variables, and that is where the multiple regression comes into picture. The remaining variability can be seen in the scatter plot, where we have in this particular example, the people who have recently joined, in this particular example, we are trying to see how there's a sample set which is of long bones and which are buried long back, and that data is given out here, right? So how much of the time, like how long it has been there buried inside, and how much it is related, how much of it can be variable based upon the nitrogen composition in the bone, right? So all of these things can be understood, right? So now the scatter plot is done in this particular way. We use a function called reg plot here, where we are going to give X as nitro and Y as time. Now you can see that all these points, right? So all of these points, like for example, in this data set, when nitro is 3.88, time is 71.8, and that is plotted digitally 3.88 and 78. So something, the plots will come here. So all those plots are made here, and this line is the linear regression line, right? So the line that that is given us, which is like the estimated line between all these points, right? So if at all these points were collinear, are there on a single line, for example, for at 4 it was at say 40, and at 3.6 it was at 70, and 3.3 it was at 90, all these points would have been collinear, and you would have gotten a line like this, but all the scattered points will be on the line. But because the data is not collinear, right? So the data is random, and for that reason there is a random distribution, but the estimated line is the the closest line that will show us the relation between X and Y, here time and nitro. Okay, so that is how we have understood. So now how do we address the unexplained variability is something we are going to understand, right? So one obvious place to start is to see if some of the other variables can help us understand why skeletons with the same nitrogen composition have different intermittent times, right? So what we are going to do is, now we have plotted times dependency on nitrogen. Maybe we can also try to plot times dependency on nitrogen and lime, right? So what the lime composition in the bones, we are going to see if there is any dependency or anything that lime is contributing to the time that the bone was buried. Okay, so how do we do that? So now first objective was to understand what is variability or what is R square, right? So how it tells the variability of Y. and if you know that r square is some number here in the model, let's say here it is 0.45, it means that it is the x is 45% contributing to the variability in r square, right? So if you understood what is r square, type u in the chat box, which is our first object. Right. So in our previous session, we have more or less tried understanding these two points only, these two lines only. Now we are trying to understand what is r squared, right? Thank you so much, Anita ma'am. Thank you, Ritesh. Thank you, Vinita ma'am. Thank you, Ravindra sir. So people who have recently joined, do not worry. Even if you are getting the brief overview of it, once you start from the beginning, you will become more clearer here. Right? Something we're not doing any complex math or anything. These are all inbuilt functions that we'll be running. Each of the function is explained in the respective module. So you do not have to worry anything. Okay. So now let's move on to the next objective. The objective is conduct a t-test to determine the significance of individual variables in the model. Right? So now if you remember the equation that we have made is y equal to mx plus c was y equal to minus 69. So if I'm just going to come here, 69, if I'm able to find. Yeah, so I'm just going to check if I'm able to do that. Yeah, so now if you see in our previous example, y equal to minus 69.24x plus 316.8. This is what we have made out from this. But if at all there is other variable that is contributing to y, the equation would be, there will be a plus another variable here, right? So we are going to try to understand that, right? So I'm just going to show it by example. Now, earlier we were doing y equal to mx plus c. Right now here the b1 is the the population's whole mean. So when you're doing in this particular way, but when you're doing it multi-regression model where you have multiple variables, you're not just going to take y equal to b0 plus b1x. You're also going to take x2, x3, right? So you are going to take 3 or more variables along with each of the coefficient, right? So the multiple regression model will look something like this. Okay, so let me go ahead. So if the equation was y equal to mx plus c, now the equation will become y equal to m1x plus m2x plus c, right? So more variables, more x, right? So this is how the equation is going to be, created on, right? So now this is what our line or the equation of the line or the equation of the model will be like, right? So let us go ahead and explore more of it. So as with simple linear regression, we use t-test to determine if model features are statistically significant or associated with the target. So let's start by looking at line, right? So now if you see one of the variable on the time of each of the bone was lime also, right? So let us see if the lime is affecting any of the y's value, right? So now how do we do that is normally what we do is we're going to plot nitro and time. And whenever we plot nitro and time, you're going to get it. But we have seen a way to also plot the third angle of it. So how do we do that? We use hue. When we use hue, it will give also that particular variable in different colors, right? So what it is the same equation. So I'm just going to remove hue and I'm going to run it. Yeah, so now what is happening? You're getting the same scatter plot, but without line differences. So now what we are going to do is write hue equal to line here. So it is going to add, because this line has two values in the data set, right? So if you look at the data set here, I'm just going to say give 30. I can see line is either 1 or 0, right? So it is a category. So it is telling if line is 1, it means it is in the category of line present. If line is 0, it means it is in the category of line not present, right? So it is a categorical variable which says lime is present or not. It is not a quantitative variable like time and depth are. Like it is giving a different quantity at different aspects. So these are quantitative variables, and here it is a categorical variable, right? So now when we add hue to it, so what is going to happen is, okay, so where are we? So I'm just going to add hue as the column line, and you can see that whenever there was line as 1, you can see that is colored in orange, and whenever the line was 0, you can see that the plots are in blue. So earlier we were thinking the whole of the plots were directly time and nitro related, but which was not visible was lines impact on the line, right? So the regression line. So if at all, now you have to see when line is 1, there will be a new line that will come here, right? So you can see the line will be here, like earlier the line was coming like this, right? So now there will be two lines. One line will be through the orange, the estimated line of the orange scatter plots, and there will be one line which will be an estimated scatter line of the blue plots, right? So are you able to appreciate here what this hue equal to lime has given more insight to us? If you have understood what we have done here with hue equal to lime, type U in the chat box. People who have recently joined, even if you have briefly understood what happened here, you can type U in the chat box. Thank you, Gopal sir. Thank you, Vinita ma'am. Thank you, Anita ma'am. Thanks, Ritesh. Okay, great. So now we've understood that it is there. So now what the multiple regression model or lines equation would be: y equal to b naught plus b1x. Here it will be of nitro, and b2x lime, right? So the equation is going to become like that, right? So now when lime is 0, this equation, this particular variable will become 0, right? So 0 into b2 will become 0. And whenever it is 0, the equation will be this. Whenever it will be 1, yeah, the equation will be all of this. So we'll see that in action, right? So now what we are going to do here is also now try to understand, do a plot of including in the equation, not just time related to nitro, but time related to nitro plus line, right? So we are also adding the column line into the equation, right? So people who have recently joined, do not worry. These will be the names of the columns in the data sets, right? So if you're talking about a real estate example, maybe you can say price, related to, let's say SFT plus location, right? So if it's a highly valued location less, right? So you can always, it's going to be, the equation is going to be that, right? But only thing that is very important is if it is a categorical data, right? Now, if you see, because lime is a categorical data, either it is 0 or 1, right? So, and when it is a categorical data, you have to add or typecast it using C. You should add a C within bracket so that the equation will know this is a categorical data, right? So this is a very important step. So whenever you are trying to do multiple regression, and whenever you are trying to see if a categorical data is impacting your equation or model, you need to cast it between the capital C and the parenthesis. So if you have understood that, type U in the chat box. Let me clear the audience. Thank you, Anita ma'am. Thank you, Vinita ma'am. Thank you, Ritesh sir. Okay, so now what we are going to do, yes, no, we are going to use the same OLS equation and we are going to do the model.summary, right? So we are going to print that. Okay, so when we print that, so what is happening? Now you can see that in the equation, because we have added in line, earlier the R square was 0.45, which means that the time was the 45% varying because of nitro alone. Now, because of the new variables that are added or removed from the equation, the impact on Y has become stronger, right? Now it has become 0.776, meaning 77.6% of the dependency of Y is coming from nitro and lime together, right? So now if you have understood what happened here, right? So that is what R square gives us, and this will become your new equation. Yes, Ritesh. So that comes in flow. Thank you so much. Even that is not a problem. We all, do that. So now, what another thing that you might have noticed is now here the C line also came in your list of items here, right? The coefficient, the standard error, the t value, the p value, all of this has come here. Now you can see that in our previous sessions, people who have recently joined, you will understand this as you watch our previous sessions. But the p value, if it is less than 5%, which means that it is statistically significant, meaning it is valuable, right? So it is something that is impacting actually, right? So all of these are less than 5%, meaning that these are statistically significant or important for our equation, right? So now this also came in. What this made, because we have now two variables, it will become easier for us to chalk out a new equation, right? So which is earlier we are doing y equal to the nitro into x plus intercept. Now what we are going to do is the equation will become y equal to intercept, which is 180.47 plus, if you remember, the b naught x nitro, right? So here nitro is minus 35.6 x nitro plus 25.45 x lime, right? So now this is the new equation or model that you have developed, right? Now whenever the lime is 0, so when lime is 0, because lime has two values, either it is 0 or 1. So when lime is 0, this particular portion of the equation becomes 0, and this will be your equation along with nitro. And when the lime is 1, this will become your equation, right? So now this is how you have created a model which is dependent on not just one variable, it's also dependent on multiple variables, right? So if you have understood this, type U in the chat box. Okay, so these values, if you see here, madam, in the Vinita ma'am, so if you see here coefficient, right? So this is the coefficient, like in our previous models also, what we have done is, I'm just trying to search where we did the model summary. Yeah, so in our previous model summary, the coefficients were giving us the equation, right? So because y equal to minus 69.24x plus the intercept. Similarly, here, our new equation is, it will come from the OLS model summary only. So y equal to intercept plus, nitro x plus lime x, right? So you have, this is what we have done here. I hope that answers. Yeah. Thank you, Ravindra sir. Thank you, Gopal sir. Thank you, Anita ma'am. Thank you, Anita ma'am. Okay, so now we have understood this. Now, sometimes what happens is, we are not satisfied with 0.77. It is 77.6% of that factor of y, the variability you have figured out, but you want more, like, maybe you want to have a 90% assessment, right? So for example, if you're going to purchase a vegetable. Now, what are the variables there? It's basically the quantity is the major of it, right? If it is per kg, this is major, but slightly other things also is your decision might be varied based upon the quality of it, the freshness of it, right? So there are like very little variables there. So then you will have 90% of your dependency on weight, given it is fresh, right? So that is how this thing is there. But now you have got 77% only, even including two variables, right? So at this same moment, we are trying to understand what is this adjusted R square, right? So now this is a variable that you have to keep in mind in whenever you are doing a model summary, right? So I'm just going to search for my previous adjusted R square in our model that we have developed here. Where is that? Okay, this is the first one. Okay, I'm going to our previous. Yeah, so if you see when we had only one equation, when we had only nitro and time going in the equation, your adjusted R square was 0.43. Okay, now what happened is when you added another variable, it has become 0.762. So when adjusted R square increases, it means your equation has improved, right? So earlier the equation was 0.433, like, because you are not comparing it with others. Here it is not not heavily valuable. But now what happened here is, as we have proceeded forward, now you can see that it has increased, meaning that is more strength on the concepts, right? So I am just Sumit sir, I am not able to see you and you're trying to reach out to me. Okay, fine. Now, adjusted R square is always helpful when you're trying to do a comparison point, right? So for example, now adjusted R square increased, meaning that your dependency is more strengthened, right? So now what we are going to do is, let's say we are trying to see if R square or the variability is going to increase if we add more variables. So maybe we are trying to understand from the data set here. Let's say, where are we? Yeah, so let's say this is our data set. Okay, I cleared outputs now, so I'm sorry. Okay, I'm just going to do it. I'm going to run from here. So now if you see this data set, cool. Now what is happening? We had multiple columns here: time, nitro, lime. So we have seen the equation of all of these together. We have got our multiple regression model or the equation. Now, if at all, we also want to see if depth of where it was buried is also impacting time heavily or not, right? So if it is buried deep inside or a little towards the ground, are we able to see that the time is getting affected or not, right? So how do we do that? We are going to add it to the equation, and then we are going to observe the adjusted R square, right? So when you check now with this equation, it is 0.762. If it is going to decrease, you're going to see that there is no actual value that this new variable added. But if it is going to increase, meaning that the other variable also helped your equation. Okay, right? Sometimes you'll not every time get 100% here, because sometimes the dependency of y could be on a few areas which are not in the data set, some things that are unknown also, right? So now let us go ahead and see if depth is contributing anything in this particular equation. Now let's go ahead and also bring in depth in this particular equation, right? So let's say we are not happy with 76%, and we also want to see if depth is contributing anything. So now what we are going to do, because depth is a quantitative value, we're not casting it with C, right? So we are directly using plus depth here, and creating our model, right? So now the model, we are going to, this will create the model. This will print the model summary. Okay. Now, first insight is like your adjusted R square decreased, right? How much it was earlier? It was 762. From our previous time, the adjusted R square increased, giving us a clear picture that it has become strengthened. But from this to adding depth, it has decreased, right? So we're also going to understand more of it. Now you can see here, depth also got added here on the line. But now if you can see the P value of P here, which is greater than 5%, meaning that it is not statistically significant. What is the people who have recently joined? What is meaning of statistically significant? It is not actually that significant for us to go ahead and use it in insights, right? So now we have understood, like you can see that this is definitely higher. And if at all the people who have attended previous sessions, if at all you wanted to take the H naught or the initial null hypothesis, the dependency of time over depth, right? First, you can also make an assessment here, right? So that is all here. So now what is the explanation, right? So in this case, we see that we fail to reject the null hypothesis, and we conclude that after accounting for nitrogen composition and burial with lime, burial depth is not associated with the intermittent time. So it is not associated with the intermittent time. So it is not actually giving us any high value of association. So in our model, we will exclude depth as a feature, right? So it is not required for us to include depth in this particular case. So we will choose not to include burial depth in our model for the intermittent time, our current best model, right? So as a data scientist or analyst, your major role is in coming up with the best model, right? So till now, your best model was this particular equation, which included the line. When you did the first time, you got a relation, the equation, but using multiple regression, you have achieved the best model till now, right? So now depth is not contributing to your equation. So if you understood this, that based upon the adjusted R square and also a few values here, right? So the value of the coefficient here is very little, and the p-value is also higher than 5%. So based upon that, we are not going to include depth in our equation, right? So if you have understood what we have done here, type U in the chat box. Yes, thank you, Venkatrao sir. Thank you, Gopal. Thank you, Gopal sir. Thank you, Ritesh. Thank you, Vinita. Okay, great. So now we have done. Now, thank you, Ravindra sir. Now let's say now, because as a scientist, you have to experiment and explore, right? Now, okay, if depth was not contributing, is age contributing, right? So now you're going to just add here. You understood the multiple regression concept already. Here, you're just trying to explore more, right? So this we'll be concluding our learning of multiple regression here, but you are going to see if you can make your best model even better, right? So can you do that? So we are going to do it with age, and you're going to use the same equation. Here, what you're doing is you're going to say plus age instead of depth, right? So if you look at the data set here, now how is age? Age is also quantitative. It is not specifying any category. If age were 0, 1, 2 only, which says 0 means age between 10 to 100, 10 to 20, 20 to 40, something like that, it becomes categorical, but it is quantitative here. So that is the reason we're not casting it with the C, right? So depth is done, age, right? So now we're going to run this. Now you can see that here also it is higher than 5%, and your adjusted R square also decreased from what it was actually, right? So again, we accept our null hypothesis and conclude after accounting for nitrogen composition and burial with lime, age at the time of death is not associated with the time. So the adjusted R square also is modestly decreased. Now earlier R square here, let me just go. So earlier here it was 776. Now here it is 777. Now the adjusted R square. So okay, sorry. Adjusted R square was this. I am looking at R square only. So adjusted R square is 755. So the adjusted R square also modestly decreased as we added burial depth or the age also, right? So I hope this was clear, right? So based upon the p-value, based upon the adjusted R square, you were able to understand if that is going to make an impact in the equation or not, right? So the best equation till now, whatever we have found, was the previous equation that we have explored. This would be the equation, right? So this is how you do multiple regression. In linear regression, we were doing it only with one variable. Here you are seeing the variability of y with respect to multiple other columns or other features, right? So I hope this was clear. And if all of this is clear, type C in the chat box. Great. Thank you, Anita ma'am. Thank you, Ritesh. Thank you. Right. So anybody who is, thank you, Vinita ma'am. Thank you, Ravindra sir. So anybody who has joined recently and was able to make a little of it, if you are able to make anything, yeah. Thank you. Thank you, Vijay. Thank you, Prashant. Okay, so that is great, and we are going to continue pick up from where we are leaving it. So we are going to conclude today's session till here on understanding of it, and as we proceed forward, there are a few more things that have been explained, which is the interaction effects. Now we have seen the plus here in this particular case. In our upcoming session, which will be on Friday and then Saturday, we are going to understand what are these interaction effects, and then we'll conclude that 2 modules and then go into our 3.4. Okay, so I hope this session was valuable, and looking forward for the next session. If there's any question, you can put it in the chat box. Else, we can conclude our session and you can safely drop the call. People who have questions, maybe you can stay towards the end and ask your question. Thank you, Venkatrao sir. Thank you, Ritesh. You can safely drop the call.